Hello and welcome to Empowered Learning. This particular lesson will be on examples of how we look at the trigonometric functions as even or odd functions, or put another way, a way to look at the trigonometric functions as being symmetric about the y-axis, which is even, or the origin, which is odd. So we have an example here to where we see cosine of t is equal to 0.8 and cosecant of t is equal to -3, and we want to find the following. So the first two examples that we have is cosine of minus t. So we know that cosine is a even function, so we know that this would be the same as saying cosine of the positive of that particular angle, since we know that for even functions, for every point xy, we also have another point negative xy as well. Moving on to the second example, we know that cosecant is just the reciprocal of sine. And so sine is one of those functions that is an odd function. So that means for every value of, or every point xy, we would have another point negative x, negative y. So this ends up being 1 divided by the negative of sine of a positive t, which gives us a negative cosecant of t. So we'll go ahead and move on and do the last two examples now. So we have secant. We know that secant is the same as 1 over cosine. And since cosine is an even function, that will just be 1 over cosine t, which gives us just secant of t. And so for our last example, we'll look at tangent squared and secant squared and do it together and see what we get. So for tangent, we know that tangent is an odd function, so we will come and do the following. So we know that this will be a minus tangent of t, and that will be squared. And we know secant is an even function. So if we rewrite that, we know this is just secant squared, or secant of t squared. We'll just write it like that. And so from here, we see that this ends up being a negative. Anything negative squared is going to still end up being positive. And then we have minus, and then we will do secant squared. Now, this is what this ends up being, but if you remember, this may actually resemble some type of trigonometric identity. And so we want to check that out to see. So to look at this, we could take sine squared, which we'll just call s here, and cosine squared and have that equal 1. And so what we can do here is either divide both sides by cosine squared or sine squared to see the identity. I'm just going to choose to do both sides by cosine squared. So if we do that, we see that this will end up giving us tangent squared of t in this case plus 1 equaling 1 over cosine, which in this case will be secant squared of t. And so if we wanted to write this in terms of everything in terms of secant, we see that tangent squared of t is the same thing as secant squared of t minus 1. So knowing that, what we could do is come back here, and in place of tangent squared t, what we could do is just write this as secant squared of t minus 1, and then put a minus secant squared t there. And of course, these cancel to 0, and we see that our actual answer ends up being a -1. And so this would be an identity, because no matter whether t was positive or negative, or what the angles are, it would always end up being 1 no matter what. So we've done our first example. Now let's move and shift to our second example. So our second example asks us to simplify the following expression. And so what we're going to do is write everything in terms of sine and cosine and see how we can deal with this to get it as simple as possible. So we'll rewrite what we have here. And of course, we know to begin with, we know that secant is just 1 over sine of minus x. Tangent is the same as sine of minus x over cosine of minus x. And then, of course, we just have sine x there. Continuing on, we know that sine of minus x and sine of minus x will reduce to 1 here. And we know that cosine is an even function, so this will just give us cosine of a positive x here times sine of a positive x. And of course, if we multiply that all together, we end up getting sine x divided by cosine x, which ends up giving us tangent x. So we see that this whole expression here, cosecant minus x times tan minus x times sine of x, just ends up being tangent of x once we're done. And so this concludes the examples for this particular video.